Welcome to the chapter on valproic acid dosing and drug concentration predictions. Valproate has been used for many years as an anticonvulsant, but it does have other indications as well. Therapeutic monitoring occurs most commonly in the setting of use as an anticonvulsant. In this video, we will estimate concentrations based on an administered dosing schedule and consider the impact of switching between regular release and extended release oral products with differing bioavailability and how that impacts average steady-state concentrations. I hope you enjoy the video.
Let's begin with the patient case. We have a 60-year-old male patient who weighs 100 kilograms with an ideal body weight of 80 kilograms, and he's to be given valproic acid for treatment of seizure activity. We want to predict the steady-state average concentration if the patient is given valproic acid regular release capsules 500 milligrams every 8 hours. First, we should determine the estimated pharmacokinetic parameters from the population values. The clearance of valproic acid is estimated to be 0.009 liters per hour per kilogram times a patient's ideal body weight. Our patient has an ideal body weight of 80 kilograms, so when we plug that into the formula, we end up with a clearance of 0.72 liters per hour. The bioavailability of valproic acid regular release capsules is 0.95. So let's do the calculations. First, we have our equation to determine the steady-state average concentration. And what we need to do is plug in our values. So the S is 1. The bioavailability F is 0.95. The dose we're using is 500 milligrams. The clearance 0.72 liters per hour. And the dosing interval 8 hours. That gives us an estimated average steady-state concentration of 82.47 milligrams per liter. Now let's depict that pictorially with this graph of the average concentration at steady state for a 500 milligram dose given every 8 hours. We see the concentration time curve rise up, and because it's an oral dose requiring absorption, it takes a while to get to the peak, and then we get to the elimination phase. The average steady-state concentration is about halfway between the peak and trough and approximately halfway in the interval in many cases. And that concentration, as we predicted, was 82.47 milligrams per liter. Let's continue the case. We're going to switch our patient to Depakote ER, which has a bioavailability fraction of 0.87, and we're going to give 750 milligrams every 12 hours. The extended release product would be expected to be able to be dosed over a longer interval. Will this have an impact on the average steady-state concentration since the total daily dose is the same, that is 1500 milligrams per day, or 750 every 12 versus 500 every 8? What may happen to the peak and trough concentrations? Well, here are the calculations. Again, our formula for determining the average steady-state concentration, plugging in our values, the key difference being that the bioavailability is 0.87 instead of 0.95 for the regular release capsules. The CSS average is predicted to be 75.52 milligrams per liter based on these numbers. So you can see we did have a slight decrease, and let's look at it pictorially. There's our concentration time curve on a 500 milligram dose given every 8 hours at steady state. The CSS average, if you remember, was predicted to be about 82.5. And then when we give the sustained release product, our actual CSS average on that was predicted to be about 75.5. And you can note the differences that might be expected from a sustained release or extended release product compared to a regular release product, where the peak on nearly equivalent doses would be less because the absorption is slower, and the trough would be higher for the same reason.